Unit 1B, Lesson 2, Interpreting the Structure of Expressions. This lesson is going to involve a lot of vocabulary, and we're also going to go through how to organize expressions so that we can easily identify key parts. To start this lesson, we have a little vocabulary to go through: terms, factors, coefficients, degree, and standard form. So first, talking about terms. Term is a number or product of a number and variables raised to a power. Usually terms are going to be separated by addition or subtraction signs and expressions. Next, we have factors. A factor is a number or quantity multiplied by another number or quantity. Coefficients, it's a number multiplied to a variable. Leading coefficient is the coefficient of the highest degree term. That'll make a little more sense later on. Next, we have the degree. This is the exponent on a variable term. When we're talking about the degree, often refers to the highest degree of an expression. And then the last one is standard form. Writing the terms of an expression from highest degree to lowest degree, so writing them from the highest exponent to the lowest exponent. Standard form allows us to quickly identify some of these key parts when talking about expressions. Now on to the first example. An expression of the fifth degree is written with a leading coefficient of 7 and a constant of 6. Which expression is correctly written for these conditions? Okay, so before we go through those, let's talk about some of these key vocabulary terms we just referred to dealing with our first expression: 6x to the fifth plus x to the fourth plus 7. Okay, so I'm going to rewrite this slightly differently. We have our 6x to the fifth plus, I'm going to put a 1 in front of the x to the fourth. Since this is a 1 in front, 1 times anything is just itself, so normally we don't write that 1 there. Also, when we have just that 7 in the original expression, that is the same as having 7 times x raised to the 0 power. Because like we talked about previously, anything raised to the 0 power is 1, so that's just understood not to be there. Since we know x to the 0 is equal to 1, 1 times anything is itself. Normally we don't write that in there. I'm just writing it so we can see some of these vocabulary terms. So when dealing with the terms of an expression, that is referring to 6x to the fifth is one term, 1x to the fourth is a second term, and then 7 times x to the 0 power is a third term. Remember, terms, we could tell in expressions, are separated by addition or subtraction signs. So in this case, we have 3 terms. The degree is referring to the exponents on the variable. So we have a degree of 5 on this term, a degree of 4 on this term, and a degree of 0 on this term. If we were talking about the degree of the expression, then we would just be looking for the highest degree on any term, which would be 5 in this case. And then we also have the coefficient. And the coefficient is the number multiplied in front of our variable terms. So we have a coefficient of 6, we have a coefficient of 1, and we have a coefficient of 7. When dealing with this coefficient of 7, if that coefficient is multiplied by a variable term with a degree of 0, normally we're just going to call that a constant. So anytime we have a number by itself in the expression, it's multiplied by x to the 0 power, that's just referred to as the constant. This expression is also written in standard form because our terms are written in sequence from our highest degree 5 down to our lowest degree 0. Okay, so there's a lot of information there. If you need to rewind this to go through all that information again, that's probably something you want to do. One thing I forgot to go through is the leading coefficient. Whenever you see LC, that means the leading coefficient. In this case, the leading coefficient is going to be 6. Recall from the definition previously, the leading coefficient is the coefficient in front of our highest degree term. If our expression is written in standard form, the leading coefficient is simply going to be the first coefficient in that expression. Now that we've reviewed all of those main ideas and hopefully you have a better understanding of those terms, now we'll go back to the original problem An expression of the fifth degree is written with a leading coefficient of 7 and a constant of 6. Which expression is correctly written for these conditions? So of these four, we want to find the one that has those three conditions met. The first thing I notice is that all of these expressions are written in standard form. They go from highest degree to lowest degree. 540, 640, 750, 520. So if I am looking for an expression with a leading coefficient of 7, I just have to look at the first number on any of these expressions. This one has a leading coefficient of 6, so that's not going to work. And this one has a leading coefficient of 6, so that's not going to work. Next, we want an expression with a fifth degree. So the highest exponent is going to be a 5. Well, if I look, highest exponent I have here is 6, so this would be the sixth degree, so that one's not going to work. So the expression that must be true is number 4. It has a leading coefficient of 7, a degree of 5, and it also has a constant of 6. Now on to example 2. When multiplying polynomials for a math assignment, Pat found the product to be negative 4x plus 8x squared minus 2x cubed plus 5. He then had to state the leading coefficient of this polynomial. Pat wrote down negative 4. Do you agree with Pat's answer? Explain your reasoning. Okay, so first of all, polynomials, don't worry about that definition. You've probably heard the term before, might not remember what they are. We'll talk about that together in class. The first thing I would do to see if Pat is correct is first rewrite this expression in standard form, so from highest degree to lowest degree. If we wrote that expression in standard form, we'd have negative 2x cubed plus 8x squared minus 4x plus 5. Okay, listing the terms from highest degree to lowest degree. Now the leading coefficient is going to be the coefficient in front of the highest degree term, which in this case would be negative 2, not negative 4. So no, I would not agree with Pat's answer. Example 3. A store advertises that during its Labor Day sale, $15 will be deducted from every purchase over $100. In addition, after the deduction is taken, the store offers an early bird discount of 20% to any person who makes a purchase before 10 a.m. If Hakeem makes a purchase of X dollars, where X is greater than 100, at 8 a.m., what, in terms of X, is the cost of Hakeem's purchase? So we need to write an expression that models this situation. So we need to have X, which represents the cost of Hakeem's total purchase, where X has to be more than $100 for these discounts to be applied. They're going to take $15 off of that amount as long as it's over $100. After they take that $15 off, they're going to take an additional 20% from that amount, okay, as long as that purchase has taken place before 10 a.m. So we have to multiply that by 80%, because if it's 20% off of our total, that means we're actually paying for 80% of the total, which we would write as 0.80 or just 0.8. Normally, we're going to write this coefficient out in front, so we would have 0.80 times x minus 15. So here is an expression that models this situation. Another way we could have written this expression is we take the total amount, which was x, we have our $15 discount, so x minus 15. From that amount, we're going to subtract 20% of that amount. Okay, so this expression is the exact same as the one we had before. It's just the one we started with originally is the simplified version. Now to the last example. Mr. Cash bought D dollars worth of stock. During the first year, the value of the stock tripled. The next year, the value of the stock decreased by $1,200. For part A, write an expression in terms of D to represent the value of the stock after 2 years. For part B, if an initial investment is $1,000, determine its value at the end of 2 years. So right now probably would be a good idea for you to pause the video and try to answer parts A and B on your own. Okay, and then once you have attempted those, then continue the video and see the solutions. So for part A, we wanted to write an expression in terms of D to represent the value of the stock after 2 years. So we know we started with D dollars worth of stock. That was our initial investment. After the first year, that amount tripled. So we would take 3 times whatever amount we put in initially. Then the second year, that amount decreased by $1,200. So that's why we have to subtract $1,200 from that amount. So here is an expression that represents the value of the stock after 2 years. For part B, if an initial investment is $1,000, determine its value at the end of 2 years. So all we have to do is take our expression we just came up with and substitute in $1,000 in for D. So now we have 3 times 1,000 minus 1,200. 3,000 minus 1,200 gives us $1,800. So that would be the value of the stock at the end of 2 years. In this lesson, we discussed a lot of vocabulary terms relating to expressions. We also went through how to take information and write an expression that models that situation. Okay, so make sure you understand all those terms. Remember to write expressions in standard form to make identifying those key parts easier.